linear programming problem. You must have done this in your 12th standard. I don't know about the DSC students, whether they have done this. But in 12th, we have done linear programming problem. So mostly in all the business, everywhere we apply this linear programming problem because the main aim of this problem is to maximize the profit and minimize the cost. Okay. So any businessman, they want to maximize their profit and minimize their cost subject to some conditions of availability of the manpower or machines, etc. So here the general form of a linear programming problem, in short, we say it as LPP. The general form of an LPP is minimize or maximize. You will have maximize Z or minimize Z equal to C1x1 plus C2x2 plus C3x3, etc. Cnxn, subject to some conditions, some inequalities or equalities you will have over here. You don't have the formation of any LPP, you just have to solve by different methods. The general form is you have maximize or minimize Z equal to this, then you have some conditions here, some constraints here, and the last one is all the variables are greater than or equal to 0. Equation 1 is called as an objective function because our objective is to maximize the profit or minimize the cost. So the first equation is called as an objective function. Second equation, all these equations are called as constraints, and the third equation is called as the non-negativity constraint. Okay, so you will have some function maximize Z equal to something, then you have subject to some conditions, and then you have that all the variables are greater than or equal to 0. So maximize or minimize functions are called as objective function. Equation 2 is called as the constraints. Equation 3, that is all the variables are greater than or equal to 0, is called as a non-negativity constraints. These C1, C2, C3, etc., Cn are called as the cost function. Okay, C1, C2, C3 are called as the cost. B1, B2, B3, etc. The right hand side of each constraint is called as the stipulations. Okay, the right hand side of each constraint is called as stipulation, or I will say right hand side of each constraint. C1, C2, C3, etc. are the cost. Now, any values of x1, x2, x3, etc., xn satisfying equation 2, any values of x1, there are n variables here, x1, x2, x3, etc., xn. Any values of x1, x2, etc., xn satisfying equation 2 or the constraint is called as the solution of a linear programming problem. Any values of x1, x2, x3 satisfying equation 2 is called as the solution. If the solution satisfies the third condition also, if it satisfies only these equation, it is said to be a solution. But along with this, if it satisfies equation 3 also, it is called as a feasible solution. And any feasible solution which maximizes or minimizes the objective function is called as the optimal solution. Okay, so here in the next slide, C1, C2 are called as cost coefficients, B1, B2 are called as stipulations. Any set of values x1, x2, etc., xn which satisfies the constraints 2 is called as the solution. Any solution which satisfies equation 3 is called as a feasible solution, and any feasible solution which satisfies the objective function is called as an optimal solution. So our aim will be to calculate a feasible solution, which means that the values of all the variables should be greater than or equal to 0. Okay, so all the variable values should be greater than or equal to 0. Then it is said to be a feasible solution. And any feasible solution, if it is not feasible, then we will not get the optimal solution. It has to be a feasible solution to get the maximized Z or the minimized Z. There are two types of LPP. One is called as the canonical form. Other one is called as the standard form of an LPP. There are First, I gave you the general form of an LPP. You will have an objective function, you will have a constraint, and then you have a non-negativity constraint. Objective function, if any set of values satisfying equation 2 is called as solution, satisfy equation 3 is called as feasible, and any feasible solution which maximizes or minimizes the objective function is called as the optimal solution. Two types of LPP, canonical form and standard form. So we will see what are canonical form and standard form. Now, canonical form. The first condition is objective function is of maximization type. In the canonical form, the objective function should be maximization. If it is minimization, then you have to convert the minimization problem to minus maximization of minus z. Okay, in the canonical form, objective function or equation 1 जो था, that has to be a maximization function. अगर वो maximization नहीं है, but you have a minimization type, then it can be converted to a maximization problem by converting minimize z is equal to minus maximization of minus z, or I can also replace minus z by some variable. Okay, that is equal to z star or something like that. Second condition, the right hand side, or I say stipulations, the right hand side of each constraint, constraint is equation 2. The right hand side of each constraint should be non-negative. Now, what do you mean by non-negative? इसका मतलब क्या होता है? What is non-negative? Difference between non-negative and positive is what? Anybody? A division, please unmute yourself. I'm not having the chats here.
It can be 0.
Which one? Non-negative, right?
Yes.
Yes. Non-negative में the variable that the right hand side can be 0. Positive में क्या होता है? It starts from 1, 2, 3. When I say right hand side of each constraint should be non-negative, इसका मतलब होता है 0 भी हो सकता है. 0, 1, 2, 3, 4, etc. The right hand side of each constraint should be non-negative. और अगर suppose negative है, suppose you have a -4 here, then multiply this inequality by minus sign and make the right hand side as a positive number. Okay, it has the right hand side of each constraint should be positive, should be non-negative. If you have any negative number, multiply throughout by a negative number so that we will get the right hand side positive, and when you multiply an inequality by a negative sign, we will get the inequality will get reversed. So we will have minus 2x1 plus 3x2 greater than or equal to 4. So पहला कंडीशन है ऑब्जेक्टिव फंक्शन, मतलब इक्वेशन 1 जो है वो मैक्सिमाइजेशन होना चाहिए. अगर मैंने मैक्सिमाइजेशन नहीं है तो यू कैन कन्वर्ट दैट मिनिमाइजेशन टू माइनस मैक्सिमाइजेशन ऑफ माइनस z. Right hand side has to be non-negative. If it is negative, then multiply throughout by minus sign, change the inequality and make the right hand side positive. Next, third one is an inequality is changed. An equality is changed to inequality. Suppose in the constraint you are having an equality constraint. Suppose in the constraint you are having an equality constraint, then it has to be converted to an inequality. तो हम कैसे convert करते हैं? अगर if you have equal to 4, तो इस equal to 4 को हम दो constraints में लिखेंगे. One will be less than or equal to, other will be greater than or equal to. ठीक है, and equality is changed to inequality. अगर यहाँ पे equality constraint है तो हम एक constraint को दो में divide करेंगे. One will be less than or equal to, other one will be greater than or equal to. So common we have is only equal to. Satisfying both means it has to be equal to only. So writing this as less than or equal to and greater than or equal to. The last condition is all the variables should be non-negative, or all the variables are greater than or equal to 0. whatever variables we have in the LPP, all the variables should be non-negative, or I can say that all the variables are greater than or equal to 0. Suppose you have one variable negative. Okay, we say that it is unrestricted. अनरिस्ट्रिक्टेड का मतलब होता है कि कुछ भी हो सकता है, पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है. देन व्हाट वी डू इज, नाउ फॉर एग्जांपल सपोज यू हैव -5. -5 is a negative number. You can write -5 as 2 minus 7, where 2 is positive, 7 is positive. है ना? -5 can be written as 2 minus 7. 2 positive है, 7 positive है. उसके बीच में माइनस साइन है. Okay, when you say, so we can write, if suppose if there is any variable which is negative, we can write that negative variable as difference of two positive numbers. Any unrestricted variable can be written as a negative or the difference of two positive numbers. So we have x1. Suppose x1 is unrestricted, we can write x1 is equal to x1 dash minus x1 double dash, where x1 dash, x1 double dash is greater than or equal to 0. Just you can see this example. -5 को हमने लिखा है 2 minus 7. 2 positive है, 7 positive है. As it is, if you see 7 is positive. So we are writing -5 as a difference of two positive numbers, where and these 2 and 7 are greater than or equal to 0. So x1 dash, x2 dash is, x1 double dash is greater than or equal to 0. तो 4 conditions है. पहला है ऑब्जेक्टिव फंक्शन हमेशा मैक्सिमाइजेशन होना चाहिए कैनोनिकल फॉर्म में. राइट हैंड साइड हमेशा पॉजिटिव होना चाहिए. एंड अगर कोई इक्वालिटी है, इक्वल टू साइन है, तो उसको 2 में कन्वर्ट करना है, लेस देन और इक्वल टू और ग्रेटर देन और इक्वल टू. एंड ऑल द वेरिएबल्स आर नॉन नेगेटिव. That means all the variables are greater than or equal to 0. But if you have any one variable negative, that can be written as a difference of two positive numbers. Okay, so clear this part. Any doubt? We will not be using canonical form in the future problems. We'll be using only standard form. So not much difference between the canonical form and the standard form. All the three are only this one there is a change in the standard form. Rest everything is the same. If you have any doubt, you can unmute yourself and ask. Otherwise, I'll go to the next slide. Okay, so I'll move to the next slide. What is the application of this form? It is everywhere it is applied. Any business or any manufacturer, they all want to have a maximum profit subject to the availability of some constraints, like subject to the availability of some machines, subject to the availability of manpower, or maybe there's different constraints. Okay, subject to that, how to get maximum profit. Okay, that part is explained by this LPP. Once you solve by this method, the businessman knows how to get the maximum profit out of the available resources. So it has a major application everywhere in real life. Everywhere they're applying LPP to calculate all their profits, how to maximize their profit, minimize their cost, and all those things. Okay.
No, madam. I was asking about what are the application of this canonical form.
No, this is all used to solve an LPP. Canonical form and standard form, they are used to solve an LPP. तो नॉर्मली क्या होता है, हम लोग का भी सिलेबस खाली स्टैंडर्ड फॉर्म को से सॉल्व करना है. बट सपोज यू वांट टू सॉल्व, यू हैव टू एक्सप्रेस दिस LPP in the canonical form and solve by some particular method, because there are some methods which uses canonical form also. Okay, that is only a method. If you are given a particular method to solve, then you have to make use of, you have to reduce that LPP to canonical form or a standard form. Only for that purpose we are studying this. Okay? Yes, clear?
Yes, ma'am.
Okay. So we'll move to the standard form. Same hai. First condition is same. Second condition is also same. Third condition, there is a change. All the constraints are expressed in the form of equations. वहां पे क्या था? We were having equations. We were converting those equations to inequalities. Here we have, here all the constraints we should express those constraints in the form of equalities or equations. Now suppose you are having 2x1 minus 3x2 less than or equal to 4. ठीक है? Now, what is the meaning of this? I can say that there is something less on the left hand side. When I say the left hand side is less than or equal to right hand side, उसका मतलब होता है कि there is something थोड़ा something is less on the left hand side. तो हम क्या कर सकते हैं, उसको एक वेरिएबल ऐड करके इक्वल कर सकते हैं. सो आई कैन राइट दिस एज 2x1 minus 3x2 plus s1 equal to 4. सपोज यहाँ पे राइट हैंड साइड में 4 है, एंड इफ आई एम गेटिंग लेफ्ट हैंड साइड एज 3, so 3 plus 1, if when I add, we will get the answer as equal to 4. So that something is called as the slack variable, a variable which is used to which is added in the less than or equal to constraint to convert an inequality to equality is called as a slack variable. If something is less than on the left hand side, so to make it equal, we are adding something on the left hand side so that both the sides are equal. So 2x1 minus 3x2 plus s1 equal to 4. This s1 is called as a slack variable. Suppose you have ulta, then what do? Left hand side is greater than the right hand side. तो क्या करेंगे हम लोग, इक्वल करना है तो अगर लेफ्ट हैंड साइड कम है तो हम कुछ तो ऐड करते हैं उसमें ताकि दोनों इक्वल हो जाए, और अगर हमको राइट लेफ्ट हैंड साइड ज्यादा है तो हम क्या करेंगे इक्वल करने के लिए, we will subtract something from there, है ना. You have left hand side is greater than the right hand side. So to make this as equal, you have to subtract something from the left hand side. So that becomes, that variable is called as the surplus. You have some variable, you have some number which is surplus. So take out that amount outside. So minus S2. We are subtracting a surplus variable because it's already more. Left hand side, right hand side से ज्यादा है. तो जो भी ज्यादा पार्ट है उसको हम माइनस करेंगे ताकि both will become equal. So this is the procedure in the standard form. We have to convert an inequality to equality by either adding a slack variable or by subtracting a surplus variable. Okay, so the other two conditions are same, only there is a change in the third condition, that all the constraints are expressed in the form of equation. Again, the fourth condition is also the same, which we explained in the, which I explained in the previous one. ठीक है?
Ma'am,
तो खाली, what is that? Any doubt?
ma'am, I wanted to ask about the second year.
Ask about the
Second, that right hand side of each constraint should be non-negative.
Yes, right hand side of each constraint should be non-negative. मतलब ये negative sign should not come there. तो हमें क्या करना है, पूरे inequality को negative sign से multiply करना है. We have to multiply this inequality by minus sign so that this will become positive, and whenever, see, when I say 2 is less than 7, and when you multiply by minus 2 minus sign, we will get minus 2 is greater than minus 7. The inequality gets reversed. Okay, so whenever you have
okay,
a
so
negative,
sign will also change.
Yes, you're multiplying throughout by minus. If all the signs will change. We are
I'm
multiplying
not
throughout
asking
by
that
minus.
minus plus wala sign, ma'am. Greater than and less than wala sign.
Greater than
and less than wala sign. Like if in example you have used less than.
हाँ, अगर हम माइनस
And then,
साइन से मल्टीप्लाई, सी सपोज आई एम सेइंग 2 is less than 7, ठीक है, 2 is less than 7. अभी तुमने अगर मल्टीप्लाई किया माइनस साइन से, तो व्हाट डू वी गेट? कैन आई से -2 is less than -7? कौन सा बड़ा है, -2 बड़ा है कि -7 बड़ा है? हाँ, नंबर लाइन अगर हम लोग देखेंगे तो -2 बड़ा है कि -7 बड़ा है?
-2.
-7 is greater, -2 is greater. So when I write 2 is less than 7, but -2 becomes greater than -7. है कि नहीं? The same concept. Whenever you multiply an inequality by minus sign, the inequality gets reversed. Clear? उसका उल्टा हो जाता है. अगर लेस देन और इक्वल टू है तो यहाँ पे ग्रेटर देन और इक्वल टू हो जाएगा, एंड बाकी सबका साइन चेंज हो जाएगा. ठीक है?
Okay, ma'am.
Okay. So but in your syllabus, we'll be using only the standard form. We will not be applying the canonical form. The methods which are there in your syllabus, they all are solved by using